So if you're given the coordinates of a quadrilateral and you reflect it over the y-axis and translate horizontally, what would the coordinates be? So if you reflect over the y-axis, that's going to take your coordinates to be, your x-coordinate's just going to change from a positive to a negative. So if your x-coordinate changes, that means we only care about A primes. That's the only one I'm going to focus on. The x-coordinate changes from, in this case, negative to positive. So the x-coordinate would be 4, negative 3. It would be the new coordinates. But then you translate it horizontally, negative 3. Horizontally is on the x. You could say that's negative 3, 0 if you want to write it as a vector. So that means you subtract 3 and then you add nothing. So subtract 3, you get 1. Add nothing to that, you get, stays negative 3. So there's the coordinates for A prime. Perform the reflection and then the translation. Here we're told MP is perpendicular to LM, so we get a right angle right there. And RP, so we get another right angle right there. MP bisects LR, so LR is cut in 2 congruent pieces. What congruence criterion can be used to prove that the triangles are congruent? So we need one more thing, which is vertical angles are right there. So we have 2 angles, the side is not between them. 2 angles, the side is not between, so it goes at the end. Angle, angle, side. To find the coordinates of the centroid, you add up all 3 points and divide by 3. So 0, negative 4, negative 2. That's negative 6. 0, negative 3, and negative 5. That's negative 8. Those are the coordinates. We just have to simplify. So that's negative 2, comma. You could leave it as negative 8 over 3, or you can make it be a decimal. Either way is fine. Angle-side angle congruency states that 2 triangles are congruent if 2 angles in the included side of one triangle are congruent to 2 angles and the included side of the other triangle. What additional information do we need to prove the triangles are congruent by side, angle, side? So we have some congruent sides already that they're marked. We have vertical angles, which are now marked. We need one more thing for side, angle, side. So we look at one triangle. Look at the one on the left here. We have a side and an angle. We need the other side so that the angle is between. So we need MN congruent to the other side, so the angle is between, so that would be congruent to PN. Then we have 2 sides and the angle in between for side, angle, side. Given segment AB, the coordinates of A are negative 4, 8, and the coordinates of the midpoint are 1, 3. What are the coordinates of B? So, coordinates of B, we're going to call it XY. And then we'll use midpoint formula, which says we add the x's, negative 4 plus x, we divide by 2. Then we add the y's, 8 plus y, divide by 2. That has to equal the midpoint, which is at 1, 3. So this has to equal 1, and this has to equal 3. So negative 4 plus x divided by 2 equals 1, and 8 plus y divided by 2 equals 3. And we'll solve that out. Multiply by 2. 1 times 2 is 2. Add 4. Multiply by 2, we get 6. And then subtract the 8. So 6 comma negative 2 are the coordinates of B. Identify all the transformations that are performed given this rule. So the x and the y both stay in their spot but turn negative. That's a 180-degree rotation. And then we have +3 and -2. That's a translation. And you're just adding numbers on there. So those are the two transformations, a rotation and translation. Identify all lines of symmetry and degrees of rotation that will map the figure onto itself. So for lines of symmetry, we could go vertical or horizontal. Looks like it would also work if we went like that. We have 4 lines of symmetry. And then to figure out the degree of rotation, we can rotate it around so that matches up. The top side could rotate to here, here, or here. So that's 4 different positions where it would match up. So you take 360 degrees, divided by those 4 stopping points, you get 90. And all the multiples of 90. So 90 plus 90 would be 180. Another 90 would be 270. And then another 90 would be 360, but we don't need to write that. Find the image of the triangle if you translate it -4, 5, and reflect over y equals -1. So move it -4, 5. So our graph is counting by 1 unit, so we're going to go left 4 and up 5. Left 4, up 5. So after the translation, it ends up there. And then you reflect it over y equals -1. So sketch in that line so that we can reflect it. So we're 2 units above, so we go 2 units below. 2 units above, 2 units below. 3 units above, 3 units below. So there's where the image will end up. That is C, this is B, this is A prime. Write the equation in slope-intercept form of a line that is parallel, passes through those points. So if it's parallel, we need the slope. So make that be slope-intercept form. So parallel, we're going to keep that slope and use these points. So we go y minus -4, it's going to be +4, equals m, x minus 2. Distribute. And then add the 4 over, you get y equals 2x, or subtract the 4, minus 8.